Turn to page 25. There's a do now at the top. Pause the video while you do the do now. Questions 10 to 15. Welcome back. So you should have paused the video and done 10 to 15 on your own. So if you go through this, just do the vertical line test. Yes, this is a function. Anywhere I draw a vertical line, I will never hit more than 1 point. Number 11 is a function. Number 12, -1 goes 2 places. So that is no. That is not a function. Notice 2 numbers go on to the 5. We're not concerned about y repeating. It's only the x that cannot repeat. Number 13, this is called a step function. If I do my vertical line test, there are some places that I'll hit more than once. So this is not a function. This, everywhere on this line, I hit more than once. Oops. So this is no. Anywhere I draw a vertical line down this function will be fine. So this is a yes. As we continue to explore domain and range, we'll also explore other key features of graphs, such as areas of maximums, minimums, increase, and decrease. When we look at a graph, we want to follow a graph from left to right, just like reading a book or writing on paper. So when we follow a graph from left to right, a function is increasing when the y values increase, so when the y values increase as the x values increase. So basically, if I'm on the left side of the graph and I want to move to the right now, to move to the right, I have to head up. So when I follow my graph from left to right, I'm heading up. This graph is increasing. When looking at a graph again from left to right, I am decreasing when the y values decrease as x increases. So notice x is increasing, I'm moving to the right. As I move from left to right, I'm heading down. Since I'm heading down, this function is decreasing. So on the next page, page 26, you have a picture here on the left that shows you some examples of how a function can be increasing, decreasing, and also remaining constant at different points. So here, if I follow this little section in pink, if I move from the left side to the right, as I try to go to the right, I am moving up. So that is increasing. This next piece, as I move along, I'm not moving up or down, I'm just moving to the right. So that would be considered constant. Again, here, if I move from left to right, I'm increasing. And then finally, as I continue to move left to right, now I'm decreasing. So off on the right, a function can be constant, and we've already talked about constant functions, when the y values are the same as the x values increase. So that's this blue part right here. So as my x values increase, as I move from left to right, my y values are staying the same. So I'm constant. Some other terms you need to be familiar with are the terms relative extrema, and sometimes called local extrema. These are points that are high and low points where the graph changes its increasing or decreasing behavior. The high points are called relative maximums, and the low points are called relative minimums. Since these are high and low points relative to the points around them. So they're not the highest points or the lowest points on the graph, but they're highs and lows when compared with points around them. So for example, if you look at this graph off to the right, they have a relative min and a relative max. It's a high point where the graph, whoops, didn't want to do that, high point where the graph changed its increasing or decreasing behavior. So right here, the graph's heading down, and then it turned around and now it's heading up. So it changed its direction here, and it's a low point where it changed direction. So that's a relative min. Now here, I'm curving the other way. I was heading up, and now I'm heading down. So I have a point where I change direction as well. So this is a high point where I change direction. So it's a relative minimum. Both of these points would be called extrema. So these are extrema. As we said up here, they can be called relative extrema or local extrema. So here's just another sample graph. So here we have a relative max. When I ask you what the relative max is, we would just list the xy coordinate where that max is. So for example, this point is 1, 2, 3, 3 to the left, and 1, 2, looks like about 2 up. So I have a relative max at -3, 2. I also have a relative max over here, to the right 2, up 1. I have a relative max at 2, 1. I have relative mins down here where the graph turns around at the bottom. So this guy would be at -1, -3. And this one over here, 1, 2, 3, 4, would be at 4, -1. Remember, pause the video as you need to write some of this stuff down. So also notice the graph continues to head down when following it on the left-hand side, and it goes up when following it on the right-hand side. So our relative max and mins are not the highest and lowest points. And we don't care about these other points where the graph's going on and on forever. We care about highs and lows where the graph is turning around. Those are our extrema. Okay, so on page 27, we're going to find some extrema. And, sorry, we're not going to find extrema. We're going to find, well, we are, but we're going to find some areas where the graph is increasing and decreasing. And the way we do that is we focus on the domain of the graph. So we're only going to look left to right. So if you had your index cards, you'd put your index cards on the left to right, looking at the side that says domain. And then we want to follow the graph from left to right and say, well, what am I doing? Am I going up or down for increasing, decreasing? So I'm over here. You can see my purple mark. To get to the right side of this graph right now, I have to head down. So I'm going to put a little squiggle here that I'm heading down. So that purple piece is me heading down. If I keep moving, this pink, now I'm heading up. I get to the top, I stop, I turn around, and now I'm heading down. Okay, so this pink section is where my function is increasing. So if I had my index card, I could put my index card just so I could see the pink piece. My index card could be from here to here. So I'm only increasing in this little area here from left to right. So the domain of that little area is over to the right 1, and then 1, 2, 3 to the right 3. So I'm increasing from +1 to +3. We only want to look at the domain. When we're increasing and decreasing, we're never going to put equal signs on our inequalities because at the extrema, the highs and lows where it turns around, we do not consider it equal to because it's not either increasing nor decreasing. So no equals on inequalities. Okay, so no equal signs on your inequalities because at the top and bottom where it turns around, we wouldn't say it's increasing or decreasing. It kind of stopped and turned around. So now my purple spots that I outlined are areas of decreasing. So there's two separate ones. So we're just going to look at them one at a time. So if I took my index card and put my index card from here to here, here's where my function is decreasing. So it's over from the origin, 1, 2, so 2, so that'd be -2, and it's to the right 1. So my function is decreasing on the domain, so that's x, where x would be greater than -2 and less than 1. I'm going to put a comma here because I've got another piece where I'm decreasing. I'm also decreasing from here to here. So if I had my index card in this little section here from left to right, I'm also decreasing. So from my origin, 1, 2, 3, so over 3, and then 1, 2, 3, 4, 5 to 5. So I'm decreasing from 3 to 5. Pause the video if you need to write some of that down. Watch it again if you think that would be helpful. So now I want to know, are there any extrema? So remember, extremas are highs and lows where the graph turns around. So are there any extrema? If so, where? So I'm going to say yes, there definitely are extrema here. And now our extremas are actually our maximum and minimum points where the graph turns around. So now we're going to go answer that question. I'm going to take a sec here and I'm going to erase everything on this graph so that we can start fresh with extrema. So, or I'm going to do a quick job erasing it. Okay, I'm going to get these arrows out of the way too. Okay, so extrema. Highs and low points where the graph turns around. Well, I notice this high point over here. The graph is not turning around there. That's not an extrema. So as I go down, 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 now I'm going up, 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 I turned around right here. This guy is an extrema. So that point right here, and now as I keep going up, 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 now I'm going down, I turned around here, that guy's an extrema. So I have two extrema. This one is a low point, so that's going to be a relative min. So that point is over 1 up 2. So I have a relative min at 1, 2. This point over here is a high point where it turned around, so 1, 2, 3, 1, 2, 3, 4, 5, 6. So that point is at 3, 6. Okay, so pause the video as needed to write that stuff down. So you have highs and low points where the graph turned around. That's your extrema. We've got areas of increase, areas of decrease. Remember, we do not put equal signs on our inequalities when we're doing increasing and decreasing, because at the relative max and mins, we would not say it's increasing or decreasing. It actually stopped and turned around. Okay, let's do one more. So stop and ask yourself what's different about this graph from your other graph. I'm going to pause for a sec so you can think about that. Okay, so hopefully you noticed that the first graph had endpoints. Oops. Had endpoints, and this graph has arrows, and you already know the difference between the two when finding a domain. So now we're just going to still look at increasing and decreasing, where we focus on the domain on which the function is increasing or decreasing. So let's look at this new graph. So I'm going to start on the left-hand side. I'm over here, see my purple mark, and my goal is to get toward the right. So to move to the right, I have to move up. So I'm traveling up, 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 up. So right now I'm increasing, and I stop right here. And now I'm going to turn around, and now as I try to move to the right, now I'm decreasing. I stop right here, and I'm increasing again. This arrow on my graph implies that it's going to keep increasing forever, and this arrow here meant that no matter how far back I came from, I've been increasing for a long time, and I'll continue to be increasing for a long time. So we want to be careful of that when we go do our domain. So where's the graph increasing? So I've got a purple piece here, and I've got a purple piece here. Let's focus on this left-hand piece. So if we were going to go put our index card down, I'd put my index card to the left, and if I put an index card down from here to here, this left-hand side has an arrow, so technically I can't put a wall here and say that it stops. So that arrow, the graph's going down, but as it goes down, it's also going to the left forever. So my domain on this side for where this function's increasing is negative infinity. It's coming from negative infinity, and then it stops over here where this blue line is, which is 1 to the left. If you want to be a little more accurate, which we should be, it actually looks like it's a tiny bit before 1, like maybe it's at 0.9. So I'm going to say negative 0.9 actually. So from negative infinity, from all the way to the left until I hit this wall at the top, my graph is increasing. So I'm going to put my X in the middle, and I'm going to put my less than, less than. So my graph is increasing from negative infinity to negative 0.9. Okay, so now I'm going to look at the next piece that I'm increasing. So I'm going to draw my wall, or if I had my index card, I would put my index card from here, and then technically, if I put it here, this arrow says that I'm going to keep moving to the right as I move up. So I'm going to keep moving to the right forever, so I'll be increasing to the right forever, but I started increasing right here. So I'm increasing from this wall and then to the right forever. So this wall would be 2 to the right, so I'm going to put a comma here, so at 2. And then it's increasing to the right forever, so that would be infinity again. So I'm going to put my x in the middle, less than, less than. So this function is increasing from negative infinity to negative 0.9 and from positive 2 to infinity. Remember, we're looking at domain from left to right when we do this. So take a second and write that down. I'm going to erase the graph so that I can start fresh with decreasing. Okay, so I previously highlighted where the graph was decreasing. The graph is decreasing from here to here. If I draw a wall up where the graph is decreasing, it's from this section to this section if I had my index card. So really I want to look at that from left to right, and I wanted my pen, not my highlighter. So from left to right, my graph is decreasing from here to here. So that's a little before, notice it's a little bit before negative 1. So I want to be as accurate as possible. So I'm decreasing from negative 0.9, or you could say it's negative 0.8, so try to estimate that as best you can. And then to the right, I stop decreasing at positive 2. I'm going to put my x in the middle, less than, less than. So I'm decreasing from negative 0.9 to about positive 2. Then they asked if there are any extrema, if so, where. So remember, extremas are highs and low points where the graph turned around. So here you have a high point where the graph turned around, and here you have a low point where the graph turned around. So my relative max would be this one right here, which is to the left about 0.9, which we said before, and up 1, 2, 3, 4. So I have a relative max at negative 0.9 and up positive 4. So I could answer this question right here. Are there any extrema? Yes. Where are they? Well, my relative max is here, and my relative min is right here, which is to the right 2 and down 1. To the right 2, down 1. So pause the video as you need to copy those notes down. Okay, so if you turn to page 28, there's a your turn. I want you to take as much time as you need to go through that, and then I'm going to go through the answers to that. But you need to do it first. Remember, this is about you learning and practicing, so take the time to do the your turn on your own, pause the video while you do that, and then turn the video back on and check your answers to the your turn. Okay, so you should have just done the your turn on your own, so I'm going to go over the answers quickly. So on what domain is the function increasing? So if I start on the left and follow from left to right, from about here, it increases, and then it's going to keep going up into the right forever, so it'll increase to the right forever. So my increase is from a wall here, and then I can't really put a wall down here, it goes to infinity. So I'm increasing from positive 1 to infinity. So x is greater than 1 and less than infinity. So I'm decreasing. This has an arrow, which meant I'm decreasing from forever ago. So if I try to put my index card or a wall to the left, it keeps going to the left forever. So that would have been negative infinity. So coming from negative infinity all the way up to here, I'm on the decrease. So all this is decreasing. From forever back, however far it's been coming, it's decreasing until it hits this wall. So that wall is at 1. So x is greater than negative infinity and less than 1, my graph is decreasing. Are there any extrema? Remember, that's highs and low points where the graph turns around. Yes. I have a relative min right here. There are no high points where the graph turns around, so there are no relative max. Your relative min is to the right 1 and down 1, 2, 3, 4, 5. So to the right 1, down 5 is your relative min. Next graph. Find the domain and range on which the function is increasing and decreasing. So again, I'm going to follow my graph from left to right. So if I follow from here and move off to the right, from about down here to about here, my function is increasing. I'd say it's about -1. Could be a little bit over if we want to say -1.1. So -1.1 to 3, the graph is increasing. So my graph is increasing from -1 to 3. There are two places where the graph is decreasing. Now I have endpoints here instead of arrows. So my graph's going down, 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 down. So if I put my index cards up from here to here, my graph is heading down. So from -4 to -1, and this is a domain. And then again, I'm decreasing from here, from 3, and I stop decreasing here at 5. So between 3 and 5, I'm decreasing. So 3 to 5, I'm decreasing. Are there any extremas, highs and low points where the graph turns around? Yes. I have an extrema here and an extrema here. So here's a low point where the graph turns around. So that's left 1, or about -1.1. So that's a minimum. So -1.1, comma, -3. And then my other extrema, which is a max, is over here, over 3, up 1. Over 3, up 1. So pause the video as you need to, check your answers, and write that down. For homework, page 29 is homework. So work on that in class right now. We'll go over it tomorrow. Have a good afternoon.